Hi, it's good to see you. I hope you guys are doing well on the test we had on Monday. I will try to grade it on this weekend, so you should be able to see the grades on next Monday. Okay, so today we will talk about chapter 9, which is quadratic. So the first section of chapter 9 is solving with radicals. Okay, so what is radical? Such as square root or cubic root, those are radicals. So the key to solve the radicals is to clear, for example, if I want to clear out a square root, you can raise both sides to second power, which means you square both sides at the same time. For example, I have square root of x equals to 4. The way that I solve it is I square on both sides. Square root and square, they got cancelled. I have x on the left side of the equation. On the right side, I have 16. So we do the same thing when it comes to a cubic root, such as we have cubic root of x equals to 2. In order to solve that cubic root, we raise to third power. So x is equals to 8. Okay, but there's one thing you need to be careful, is when you're solving a radical problem, with even index, you need to check your answer. For example, what's even index? Square root is an even index. That means we need to check our answer. Okay, so cubic root is an odd index, so it's not necessary to check, but you feel free to check your answer. Okay, so now let me give you some examples. If I have square root of x plus, 7x plus 2 equals to 4. So in order to solve this equation, I need to square both sides. So I have square root of 7x plus 2 squared equals to 4 squared. So that I have a 7x plus 2 equals to 16. Now we solve for x. Now it's easy, right? You just need to subtract 2 on both sides. So I have 7x equals to 14 and then divide by 7. So x is equals to 2. Again, you can't just circle the answer. You have to check since it's even index. That means we need to check the solution. Okay, what would you do is you substitute the x equals to 2 into the original function, which is square root of 7 times 2 at 2, question mark, if this is equals to 4. So on the left side, I have a 14 at 2, question mark. We don't know if it's the left side equals to 4. But the left side is equal to square root of 16, which is square root of 16 is equals to 4. 4 is equals to 4. So that means x equals to 2 is our solution. Okay. let's do a odd index. So I have cubic root x minus 1 equals to -4. So since it's an odd index, no need to check. So to solve it, we want to raise both sides to the third power. So I have what? Cubic root x minus 1 cubic equals to -4 to the cubic. Okay. So on the left side of the equation, I have x minus 1. On the right side, I have x subtract 4. So do you think is it negative or positive? So this is equal to -4 times -4 times -4. There's 3 negative number multiplied together. That means they will become what? A negative. Because the first 2 negative signs, they cancel out, and then you use a positive number times a negative number. You eventually have a negative number. So you have a -64, and then you add 1 on both sides. So x is equal to -63. So since it's an odd index, we don't need to check the answer. I mean, no need to, but you can. So we circle our solution. Okay, what about fourth root 3x plus 6 equals to -3? Okay, fourth root, even index. We need to check. So the first step is we want to raise both sides to fourth power. The fourth root and fourth power, they cross cancel. I have 3x plus 6. Okay, so -3 to the fourth power, is that going to be positive or negative? Well, you totally have 4 negative numbers multiplied together. So they eventually will cross cancel with each other's negative sign. So you end up to have a positive number. So I have 81, positive 81 equals to 3x plus 6. And then I subtract 6 on both sides. I have 3x equals to 75. So x, you divide by 3 on both sides, is equals to 25. Okay, it's even index. We want to check our solution. So I'm going to write it in here, our little check. So fourth root 3 times 25 at 6 equals to, we don't know, that's why it's a question mark on the top, -3. So fourth root of 75 at 6, which is, we don't know whether this is equal to -3 or not. And then we have 84, fourth root of 84. We don't know if this equals to -3. But fourth root of 84 is equals to what? It's equals to 81, sorry. 81. So fourth root of 81 equals to what? It's equals to a +3. Is +3 equals to -3? Apparently it's not. So that means this is not our solution. So that means in this equation, we have no solution. We circle it. Okay. Let's have another one. X, let's say 4x plus 1 equals to 5. First of all, we see an even index. You want to write on the side and remind to yourself, hey, you need to check the solution. Okay, so what do we do in here? We have a radical terms and non-radical terms. What you want to do is you want to isolate the radical terms. So that means, look, here you have one radical terms. You want to isolate that part. That means you want this one to be the only items on the left side of the equation. So that means I want to move x to the right side. So I subtract x on both sides. I have square root of 4x at 1 equals to 5 minus x. Now you know what to do, right? You just need to square on both sides. So I have 4x at 1 equals to 5 minus x squared. Okay, perfect square. Tell me, is this equals to, this is not equals to 5 squared minus x squared. We talked about that many times in this class. This is not equal to 5 squared minus x squared. In fact, this is equal to 5 squared minus 10x plus x squared. If you forgot, please review those perfect square trinomial. Okay, and then we just solve for x. So how to solve it? We want to set the equation equals to 0, right? And then we try to either factor it or use the quadratic function. So I subtract 4x on both sides. I have 1 equals to 25 minus 14x at x squared, and then I subtract 1 on both sides. So I have 0 equals to 24 minus 14x at x squared. And then what? We factor it. So I have x, AC method. We have x minus 2 times x minus 12 equals to 0. So we have either x equals to 2 or and x equals to 12. Okay, even index, right? This is an even index problem, we say at the beginning. So that means we need to check. So let's check when x equals to 2. So I have original function 2 plus 4 times 2 at 1. If this is equals to 5, 4 times 2 is 8, 8 at 1 is square root of 9. Square root of 9 is equal to 3. 2 at 3 is equals to 5. So 5 is equals to 5. So we know that x equals to 2 is the solution, one of the solution, or maybe the only solution. And now we next check 12. Okay, so I have 12 at square root of 4 times 12 at 1. If this is equals to 5, 4 times 12 is 48 at 1 is 49. Square root of 49 is equals to 7. So 12 at 7. Well, this is 19. Apparently, 19 is not equals to 5. So this x equals to 12 is not our solution. So we only have one solution, which is x equals to 2. Okay, so let's do one problem that with two the radical terms. Okay, so first of all, what? Even index. Even index, that means we need to check. Okay, what would you do? You want to isolate the radical term or the radical roots to both sides. So that means I want to move this one to the right side of the equation by adding square root of x. Okay, guess what's the next? Yes, we square both sides. So we square both sides. I have 3x minus 8 equals to x. Now we can solve x. By setting the equation equals to 0, which means we need to subtract x. So I have a 2x minus 8 equals to 0. So x is equals to 4. Okay, again, we want to check our answer. I have square root of 3 times 4 minus 8 minus square root of 4 if this is equals to 0. So square root of 3 times 4 is equals to 12. 12 minus 8 is 4. Square root of 4 minus square root of 4, well, is equals to 0. 0 equals to 0. That means x equals to 4 is the solution. We circle our solution. Okay, let me summarize the method that we did. First of all, when you have more than one radical terms, what you do is, the first is you want to check if it's an even index. You need to write it down to remind yourself, hey, you need to check the solution. The second step is, what I do? I isolate the radical terms to each side. And then I raise it to whatever power that I need to. So the next is I need to set the equation equals to 0. The 5 is I solve for x by factoring or whatever method that you want to use. The last step is you want to check your solution, and then you circle it and determine which one is the solution. Okay, so let's do one. We follow this method. Okay, if I have square root of 2x at 1 minus square root of x equals to 1. First of all, even index. That means we need to check. Okay, we want to what? Isolate the radical terms to both sides. So I have square root of 2x plus 1 equals 2. I add square root of x on both sides. So I have a 1 plus square root of x. And then I square both sides. I raise the power. In this case, we want to raise to second power. So I have square root of 2x plus 1 equals to 1 plus square root of x squared. You want to raise the power to the whole thing of the equation, not just one term. So I have a 2x at 1 equals to perfect square trigonomial 1 squared at 2 square root of x times 1, which is equals to itself, at square root of x squared. You simplify it. Okay, what do you want next? We will repeat what we did earlier, right? Which is you want to isolate it, the radical terms, by moving 1 to the left side and moving x also to the left side. So I have what? X equals to 2 square root of x. And now we can raise to the 2 power. So I have square. So I have x squared equals to 2 squared is equals to 4. Square root of x times square is equals to x. Now you want to what? Set the equation equals to 0. So we can solve it by factoring. So x is either equals to x minus 4 equals to 0. So we have two solutions. Either x equals to 0 or x equals to 4. Now we want to check. Let's check x equals to 0 first. I have square root of 2 times 0 at 1 minus square root of 0. We don't know if this is equals to 1. 2 times 0 equals to 0. I have square root of 1 minus square root of 0 equals to itself 0. Square root of 1 is equal to 1. 1 minus 0 is 1. So that means this is equals to 1. So we know that x equals to 0 is the solution, one of the solution. And we also need to check x equals to 4. So we have 2 times 4 at 1 minus square root of 4 if this is equals to 1. 2 times 4 is equals to 8. 8 plus 1 is 9. Square root of 9 minus square root of 4, which is 3 minus 2. Well, this is equals to 1. So that means x equals to 4, also our solution. So let's recap. When it comes to an equation has more than one radical index, what you do is what? You isolate the radical, you raise the power. Well, if you find out there's still another radical, what you do is you repeat, you isolate it, the radical terms, and then you raise the power. After you solve it, you set the equation equals to 0, and then you factor it. Okay, so that's it for today. Next week we will have a quiz. So please be prepared. Have a good weekend. Don't forget my open math homework. I'll see you on Monday. Bye-bye.